Infantese 20 W20 Sim. North Africa, Italy, NW, Europe. Built for infantry pace, the Churchill began as a troubled design, yet by war's midpoint it evolved through reliability fixes and assault variants into the Allies' preferred tool for breaking fortified positions. December 1942, Tunisia Hill assaults begin. By late 1942, the Churchill's reputation was already burdened by its first high-profile trial. Dieppe, 19 August 1942. 29 Churchills of the Calgary Regiment landed. Many bellied on the shingle and stalled at sea walls, and none broke into open country. The episode echoed pre-existing concerns from trials. The early Meadows, divided by Bedford powertrain and Merritt-Brown gearbox, suffered teething failures under load, while the tall hull and complex track runs complicated maintenance. Nominal road speed was about 15 miles per hour, is approximately equal to 24 kilometers per hour, on a 39-ton early mark, but the practical issue was not top speed. It was reliability per mile, and the ability to keep moving in broken ground. As British and Commonwealth formations moved into Tunisia in late 1942, the tank entered its intended environment: steep hills, wadis, and stone farms, where traction and climb mattered more than dash. War Office AFV technical notes from 1942-43 paraphrase criticized drivetrain weakness and cooling, but praised cross-country grip and the Churchill's ability to scale banks exceeding 45 degrees. Uncertain, exact angle varies by test. Workshop returns recorded high early failure rates for fans, radiators, and final drives. Meantime between failures, MTBF, improved only after successive modification schedules were implemented in 1943. One brigade report from the winter period, paraphrase, noted that the tank could go where others will not, but that keeping them going consumed hours of field-expedient maintenance per day. In mechanical terms, the platform's liabilities were measurable: frequent coolant loss and oil leaks, repeated clutch and brake adjustments, and track shed events after side loads on rock shelves. In tactical terms, the hull showed its potential niche: a slow, sure climber that delivered infantry support guns onto high ground. The context of Tunisia made these trade-offs visible. Hill features like Longstop, Jebel El Amara, divided by Jebel El Rar, dominated road nets and river crossings. Infantry needed armor that could crawl, pivot, and hold on slopes while firing. The Churchill III's 6-pounder, 57 millimeters, lacked high explosive mass compared to later 75 millimeters. Fitz HE shell weights for early British 57 millimeters were roughly 6-7 pounds, limiting effect on masonry and fieldworks, yet the platform's suspension allowed stable emplacement on inclines and rubble where faster cruiser tanks struggled. A troop of Churchills could maintain a sustained crawl of 2-3 miles per hour on grades where other types risked stalling, an operationally relevant metric when assaults lasted hours and resupply lines were narrow tracks rather than metalled roads. Dieppe remained a shadow, as historian David Fletcher later summarized in Times Mr. Churchill's tank times, paraphrase. The August 1942 failure said more about a bad plan and immature vehicles than about the concept. The Churchill was not designed for a seawall with shingle in front of it. That was a test nobody intended. Unit diaries from the period echo this divide between concept and execution. Tank crews valued the low gearing and deep track, reporting climbs that astonished accompanying infantry, while fitters reported long nights, fan belt changes, radiator flushes, and patching of fuel and oil lines. In numeric terms, squadron readiness could sag below 70% after a hard day's cross-country movement, improving again once modification kits and spares caught up in early 1943. Uncertain. Percentages vary by unit. See later reliability table. The Churchill's armament at this stage was also a constraint on the bunker-busting mission that would later define it. With the 6-pounder optimized for armor penetration muzzle velocities around 2,800 feet per second, the available HE was scant and blast effect modest. Against stone sangars and farm complexes common in Tunisia, the gun could chip and spall but rarely collapse structures with a handful of rounds. The result was a tempo problem. Infantry waited for sappers to close or for artillery to be walked onto point targets, while the Churchills perfectly placed on the slope lacked the HE volume to finish the job quickly. A War Office note from the winter campaign, paraphrase, recommended broader HE carriage and prioritized forthcoming 75mm solutions. Even so, early hill actions hinted at the platform's future role. Commanders noticed that the Churchill, though slow, could arrive at firing positions others could not reach at all. "It will climb a house," one troop leader wrote in a message quoted later by division historians, paraphrase, a colloquial way to describe high sill climbing and trench crossing performance, often exceeding 7.5 feet ditches and negotiating 2.5 feet vertical steps under ideal conditions. These are niche but decisive metrics on a map filled with terraces, culverts, and vineyard walls. The design's thick armor, up to 89mm on early marks, later increased allowed crews to accept near misses from field guns while they jockeyed into angle. Early operations revealed a stark capability gap. Superb climbing and protection paired with unreliable mechanics and insufficient HE effect. Those findings drove the 1943 program of reliability fixes and armament changes that would transform the Churchill from problem child to specialist breacher. May 1943, North Africa and United Kingdom reliability overhauls, and the 75mm. Question. 8th Army's winter fighting in Tunisia produced a thick paper trail of faults and fixes for the Churchill. Workshops in theater and in Britain prioritized cooling, lubrication, and final drive life. War Office, AFV, technical reports, paraphrase, list a sequence of Churchill service modifications in early 1943, revised radiator cores, sturdier fan belt drives, improved air filtration for dust, and changes to clutch linings and brake adjustment intervals. The Bedford twin-6 engine, about 350 HP, on a 39-40-ton hull was not uprated, but temperatures and bearing wear were managed by redirecting airflow and by stricter maintenance routines. Field returns showed a measurable effect. Squadron readiness, after long road moves, rose markedly as spares and mod kits caught up with units. Some brigade diaries record mean time between failure, MTBF, improving from short, single-digit operating hours in rough going to figures that allowed multi-day operations without major component swaps, uncertain. Specific hours vary by unit, quantitative table to follow later in the film. The 6-pounder's limits against fieldworks remained the second theme. Tunisia's stone farms and walled terraces asked for blast, not just penetration. British gunners could fire 6-pounder HE rounds, but at roughly 6-7 pounds per shell, the effect on masonry was modest. The weapon excelled at punching through armor with muzzle velocities around 2,800 feet per second, not at wrecking embrasures. This gap drove a parallel conversation. Either add a dedicated close support Churchill with a bigger howitzer, or put a 75mm gun capable of throwing 14-15 pounds He into the existing turret ring to give each troop more general-purpose firepower. The former solution arrived as Churchill V and 8th with 95mm howitzers, hay shells 25 pounds. Filler weight varied by lot, while the latter matured through a set of conversions and new builds that culminated in the Mach 4 cast turret. And later, 7, divided by the 8 families with British 75mm armament. In numerical terms, the difference in hay mass roughly doubling from 6-7 pounds to 14-15 pounds mattered when the target was a concrete loophole or a dry stone wall that needed to collapse, not merely crack. A North African field innovation accelerated the change. Ream and unit fitters experimented with mounting the American M375mm from recovered or damaged Shermans into Churchill turrets, efforts that generated the so-called NA-75 for North Africa. Early conversions required internal mantlet rework and gun balance changes. Ammunition stowage was adapted to American 75mm rounds, already common in 8th Army supply. Contemporary notes credit a small team of officers and artificers with the prototype work. Historiography. Accounts differ on individual names and dates. Consensus places first workable conversions in 1943, with most service use in Italy, 1,944. In practical terms, the NA-75 provided two immediate metrics: effective he-throw comparable to a Sherman, shell to 14.9 pounds, typical filler to 1. 5 pounds TNT divided by Comp B depending on loader, and a serviceable armor-piercing round for mid-range duels in Italy's rolling country. Even with the Churchill's slow gearing, that mixed load expanded tactical options. Reliability changes underpinned these armament choices. A Churchill immobilized by overheating or final drive failures could not exploit new guns. War Office, paraphrase, emphasized dust sealing and routine checks. Fan belt life in desert dust improved with guard modifications. Oil cooler flow rates were monitored, and air intakes received better filtration. Units reported that, post-mod, a troop could complete 50-70-mile approach marches without shedding more than a track or two, still laborious, but workable with trained crews and a following LAD, light aid detachment. Approach speeds remained modest, typical road march, at 12-15 miles per hour, cross-country often 2-6 miles per hour, but the key delta was staying power over days, not bursts over minutes. David Fletcher later framed 1,943 as the hinge. By mid-war, the Churchill had stopped fighting its own mechanics and started fighting the enemy. Paraphrase from Time's Mr. Churchill's tank asterisk. That turn showed in procurement. Production of all Churchill marks would exceed 5,600 vehicles by war's end, and a growing share in 1,943-44 integrated the lessons: heavier armor on the 7, up to tilde, 152 millimeters on the hull front, strengthened suspension arms, and standardized fittings to carry fascines, small bridges, or demolition stores for the Royal Engineers. Those fittings foreshadowed the specialized AVRE family. But the precondition was a hull that could climb all day without boiling, then hold a firing position without shedding a track when pivot steering on rock. Combined arms timelines also tightened. With a 75mm armed Churchill or a 95mm close support variant in the troop, infantry commanders could call for immediate HE on a pillbox while artillery stayed on counter battery or smoke. At company level, this translated into minutes saved per strongpoint, small numbers repeated across a day of fighting. If a troop saved even 3-5 minutes at each of half a dozen sangars by employing onboard HE rather than waiting for sappers or guns, the battalion's assault tempo measurably improved. Reports from Italy in late 1943 would quantify this advantage more clearly, but the principle was already visible in training areas on the Downs and in North Africa's ranges. The right round at the right second changes the next hour. The 1,943 program cooling, driveline, and dust control moved the Churchill from fragile to serviceable, while the shift to 75mm divided by 95mm gave it the HE volume it previously lacked. Together, these changes reset the tank's role from tentative hill climber to reliable assault partner. May 1944, Liri Valley, Italy. The spring battles that opened the road to Rome demanded patient, repeatable breaching rather than sweeping maneuvers. The ground west of Monte Cassino orchards, irrigation ditches, stone farmsteads, and embanked lanes favored tanks that could climb, pivot in tight fields, and sit nose to wall while delivering heavy, high explosive. By this stage, Churchill reliability had improved through 1,943's cooling and driveline modifications, and the armament shift was visible at troop level, 75 mm armed Churchills and 95 mm close support variants joined units alongside a growing number of local NA-75 conversions carried over from North Africa and refined in theater. The question was practical. Could a slow infantry tank now deliver the right effects fast enough to move infantry across one strong point after another? In 8th Army sectors, several regiments fielded mixed troops in which at least one Churchill mounted a 95 mm howitzer and others fired 75 mm HE comparable to the U.S. M3 shells around 14-15 pounds with roughly 1.5 pounds of explosive filler, lot dependent. The 95 mm HE projectile was heavier, about 25 pounds, producing a larger blast and more masonry damage per round, while the 75 mm offered higher rate of fire and better ammunition commonality with supporting Shermans. Against the Leary Valley's farmsteads and culverts, this mattered. A typical drill, recorded in unit diaries, paraphrase, saw a troop roll up to a wall at 2-4 miles per hour. The 95 mm crack the face on the first or second shot, and the 75 mm guns walk and smoke into the gaps for infantry to cross. The cost was measured in time and ammunition. Rather than waiting for divisional artillery to bracket a single loophole, a Churchill troop could resolve a local block in minutes, spending a handful of rounds per vehicle. On a day with a half-dozen such blocks, that tempo dividend added up. The Italian context highlighted climbing and side-slope stability, two Churchill traits that had emerged in Tunisia. Vineyard banks and drainage ditches across the Leary could exceed 1.5–2.5 feet in vertical step. Ditch widths varied, but Churchill trench crossing capability, often quoted around 7.5 feet under ideal conditions, reduced the number of occasions when fascines or bulldozers were essential. Approach marches, though slow, were sustainable. Road speeds of 12–15 miles per hour remained typical, but the operational metric was endurance. Brigade logs, paraphrase, in May 1944, show troops completing 40–60-mile staged approaches to start lines with acceptable breakdown rates, a change from early 1943 when fan belts and radiators frequently failed in dusty conditions. That endurance allowed armor to be present at hour without having already consumed maintenance margins. The NA-75 conversions in Italy offered a pragmatic bridge between concept and production. Using salvaged or spare American 75 mm guns, workshops adapted Churchill turrets and mantlets, adjusted balance, and re-racked stowage to fit the larger fixed rounds. Contemporary accounts agree the total was dozens, not hundreds, uncertain. Exact count and distribution vary by source, but the effect in specific brigades was disproportionate. Where a troop had even two NA-75s, the immediate throw could double relative to an all-6-pounder lineup. One 8th Army memorandum, paraphrase, remarked that the mixed troop with one 95 mm and two 75 mm vehicles is economical in ammunition and time, reflecting the synergy between blast and volume. David Fletcher later characterized the Italian use as proof that the Churchill's hull, not a particular gun, was the constant. Give it the round the job requires, and the chassis will get that round to the wall. Paraphrase, Mr. Churchill's tank. Infantry tempo is quantifiable in small increments. If a platoon saved even 3 minutes per strongpoint by using onboard 75 mm HE rather than calling corps artillery, 6 such points in a morning yielded an 18-minute gain, enough to clear the next field before the defender reset. Multiply across a battalion front, and the day's line of departure moves forward by hundreds of meters with the same casualty risk. War Office notes from Italy, paraphrase, emphasize these minutes-saved calculations, tying them to ammunition expenditure. A Churchill troop might expend 50-80 rounds of 75mm hay across a day's fighting and 10-20 rounds of 95mm, but in exchange, the infantry reported fewer pauses under observed fire from barns and culverts. The math was not glamorous. It was operational. Limits remained. The Churchill was still heavy and mechanically dense. In the Leary's wet patches, tracks could mire and recovery slowed the column. The 75mm, while versatile, could not shatter reinforced concrete casemates on its own. Stubborn sights still demanded engineer charges or repeated hits from 95mm and artillery. And the NA-75 fleet's mixed lineage complicated spares. Yet by May-June 1944, the trend was clear in brigade returns. Availability figures in the mid-70 seconds to low, 80 seconds% on quiet days, dipping under sustained action, but recoverable by nightly light aid detachment work. Uncertain, exact percentages unit-dependent. Crucially, commanders could plan around Churchill presence at the point of contact, not merely hope for it. Two short testimonies capture the shift. With 75 seconds, the troop captain is not waiting for guns. He is the gun. An 8th Army training note summarized in early 1944 paraphrase. And from British maintenance staff, keep air clean and water cool and she will climb all day. Paraphrase AFV maintenance circular, Italy. Neither is praise for speed. Both describe a reliable arrival at the problem and a round match to it. In Italy, improved reliability met the right ammunition. NA-75 and 95mm Churchills delivered immediate HE at walking pace, turning the slow hull into a time, saving instrument for infantry assaults and setting conditions for the specialized AVRE and Crocodile roles that followed. February, May 1944, United Kingdom. While the Italian fighting validated the Churchill's staying power and the utility of 75mm divided by 95mm HE, planners in Britain were solving a different problem: how to force entry through fortified coastlines and inland strongpoints in the first hours of a continental assault. Major General Percy Hobart's 79th Armoured Division assembled doctrine and machines to compress engineer tasks, demolitions, bridging, obstacle clearance into minutes at the point of contact. The Royal Engineers' solution rested on the Churchill hull, reconfigured as the Armored Vehicle Royal Engineers, AVRE. Its signature weapon was a spigot mortar, the 290mm Petard, firing a short-range demolition charge often called the flying dustbin. The intent was quantifiable: deliver a 20 kilograms class projectile, is approximately equal to 44 pounds. Carrying roughly 29-40 pounds of explosive at to 60-80 meters, to shatter embrasures, casemate corners, and seawalls, while the tank sat nose-on to the target. The Petard defined the AVRE's timescale. Conventional artillery could level a bunker eventually, but in an assault landing, eventually was too slow. Infantry needed an opening in tens of seconds, not tens of minutes. Trials on concrete revetments in early 1944 paraphrase, War Office technical notes, indicated that one or two petard bombs placed at a wall-to-roof junction could breach a typical field-emplaced shelter. Heavier, reinforced targets might require multiple rounds or a combination of petard and engineer charges. Rate of fire was low. Reloading required the crew to slew the turret to a fixed angle and use a hatch to reinsert the projectile, exposing a crewman briefly. Procedures varied. Some units rigged aids to reduce exposure. Even with this limitation, the measured effect was decisive. The AVRE could cut a hole before the enemy corrected fire onto naval or field gun spots. In assault arithmetic, the difference between a 30-second breach and a 5-minute wait under machine gun arcs determined whether the following platoon crossed intact: Hobart's program paired the Petard with modular engineer kits that exploited the Churchill's torque and stable suspension. The SBG, small box girder, assault bridge, allowed a 25-30 feet class crossing, uncertain span varied by mark and site, to be laid by a single vehicle in well under a minute once in position. Fascines bundled brushwood cylinders roughly 10 feet in diameter filled ditches to create an immediate treadway. Stowage frames on the Churchill's bow secured them during approach marches. The Bobbin carpet, reinforced canvas and matting, could be unrolled to create a temporary roadway over soft sand or mud. In beach trials, a length on the order of tens of meters, uncertain, exact lengths differed by kit, stabilized the exit lane long enough for following vehicles. Bullshorn plows and demolition charges rounded out the toolbox. The engineering timelines were explicit. A single AVRE could arrive, drop a fascine in seconds, back out, advance again, and then fire a petard to break the far wall, each action measured in under a minute once rehearsed, provided the enemy's defensive fire did not disable the vehicle. Numbers framed feasibility. By spring 1944, Churchill production across marks exceeded several thousand, and 79th Armored allocated AVRE conversions to specialized assault regiments earmarked for D-Day and follow-on operations. A regiment fielded squadrons with mixes of AVRE roles. Troop tables varied, but a landing group could expect multiple AVREs per sector so that one disabled vehicle did not halt the lane. Reliability assumptions underpinned this math. Post-1943 cooling and driveline modifications had reduced the breakdown rate on approach marches, enabling planners to schedule rehearsed actions to the minute. An approach speed of 10-12 miles per hour on metalled roads and 2-6 miles per hour over rough ground was not fast, but the predictability allowed naval fire plans and infantry timings to mesh with the AVRE's arrival at the exact bunker face. Two documents captured intent and doctrine. The object is to give the assaulting troops the mechanical aids to overcome obstacles immediately on contact. Hobart directed in a 79th Armored note, paraphrase, 1944. War Office trials added a caution. Effect is certain only when the bomb is placed. Accuracy at short range is vital, and crews must rehearse. Paraphrase, AFV Petard notes, 1944. The emphasis was on choreography as much as hardware. Training films from the period show clocked drills, the AVRE halts, the Petard fires. If needed, a second AVRE lays SBG. Infantry rush the gap. Each step is timed, logged, and repeated until the serial meets the target minute mark. The Churchill's geometry mattered. A long track run, low gearing, and wide shoes allowed slow, controlled climbs onto rubble piles. In Petard trials, the recommended standoff to a vertical face was often a tank length or less to control aim, avoid ricochet, and contain debris. Procedural details varied by unit. Armor protection on late Churchills increased up to 152 mm on the FI's frontal arc, raising the crew's survivability during the brief reload exposure and against splinters from their own blast. Weight, around 40-41 tons on mid-war marks and higher on the 7, was an asset when pushing into sand or onto partially collapsed masonry. Momentum at 2-3 miles per hour proved sufficient where lighter vehicles slewed or dug in. At staff level, the AVRE forced changes to combined arms timelines. Artillery suppression windows were shortened to match the seconds-long Petard shot. Naval gunfire lift times were calculated to avoid masking the AVRE's aim while still keeping defenders' heads down. Infantry platoon leaders rehearsed exact spacing behind the AVRE close enough to exploit, far enough to avoid blast and falling debris. Logisticians tallied Petard bomb stocks voluminous and awkward to handle so that each AVRE could carry enough for multiple breaches. Carried rounds per vehicle varied, often limited by space and weight. Crocodile flamethrower Churchills, a separate but related variant, trained to follow or precede AVREs. Their flame projectors reached roughly 80-110 meters, offering a suppression effect that shaped defender behavior even when not firing. David Fletcher's later judgment fits the data. The Churchill's strength was not speed, but the ability to bring engineer solutions nose to target under armor. Paraphrase. Asterisk Mr. Churchill's tank asterisk. 79th Armored Division reports from early 1944 echo that tone, rating crews on seconds, saved at the breach point rather than miles per hour. In metric terms, a platoon that shaved 3 minutes from each obstacle across a morning's advance could finish an hour ahead over a 6-obstacle lane. The Petard and SBG were designed to create those minutes. In spring 1944, the Churchill stopped being merely a reliable infantry tank and became a system for timed breaching. The AVREs, Petard, and engineer fittings turned minutes into the decisive unit of measure, setting the conditions for Normandy's first-day gaps through sea walls and strong points. June-July 1944, Normandy. On 6 June, the mission for 79th Armoured Division's Churchill-based assault vehicles on the British and Canadian fronts was explicit. Arrive at the seawall, punch timed gaps, and open vehicle exits before defenders could recover. The AVRE's 290mm Petard and its engineer fittings fascines, SBG assault bridges, and Bobbin carpets had been drilled to the minute through spring 1944. In practice, this meant transforming an obstacle lane measured in yards of mined beach, anti-tank ditches, and concrete walls into a drivable exit in tens of seconds per action, provided suppression held. Petard bombs in the Tilde 20 kilograms class carried roughly 29–40 pounds of explosive and were fired at to 60–80 meters. Crocodile flamethrower Churchills, landing in subsequent waves and widely used through June-July, projected flame to roughly 8,110 meters, a psychologically and physically suppressive effect at embrasures and trench mouths. British and Canadian after-action notes, paraphrase, highlight a recurring sequence at Sword and Juno sectors. An AVRE troop approached at 2–4 miles per hour. One vehicle unrolled a bobbin to stabilize the soft exit lane. Another dropped a fascine into a trench or anti-tank ditch, and a third, under the same suppression window, halted tank length from the seawall to place a Petard round at a vertical seam. The measured outcome was not speed in miles per hour, but speed in engineer minutes. A ditch neutralized in under a minute, a wall holed with 1 or 2 shots, an SBG placed across a culvert in well under a minute once aligned. Where a troop repeated 3 such actions in sequence without a vehicle loss, the lane opened on schedule and follow-on traffic flowed. Where a vehicle was knocked out or bogged, redundancy, multiple AVREs per lane, kept the serial moving. Concrete examples emerged within hours of H-hour. Canadian engineers working with AVREs on Juno reported seawall breaches that allowed tracked vehicles off the beach inside the first hour after touchdown. Paraphrase. Times vary by subsector and enemy fire. At Swords Queen sectors, the push inland toward strong points such as the Hillman position required repeated Petard engagements and short-lay bridges across sunken lanes. The tactical arithmetic matched the training films. If a troop shaved 3 minutes at the wall, 2 minutes at the ditch, and a minute placing a bridge, their infantry company emerged from the beach strip 5 to 6 minutes earlier than a purely manual approach would have allowed. Scaled across 2 or 3 exits per brigade front, that gain meant dozens of vehicles clearing the tidal flat before the next artillery concentration or counterattack could fix them. Crocodiles proved more prominent after D-Day's first hours, as inland fights shifted to fortified farms and village strongpoints. Their projector units, towed in armored trailers and mounted to the Churchill's bow, delivered flame to 8,110 meters, enough to reach across a lane to a barn loophole or traverse a ditch while the hull remained in partial cover. Reports from late June and July, paraphrase, note that a Crocodile's initial burst could compel defenders to abandon a casemate or allow sappers to place charges unobserved. Fuel expenditure was tracked carefully. Projector shots consumed tens of gallons in seconds, yet the measured effect was often binary. A position either held, or after flame, it ceased to fight. Reliability underpinned all of this. Post-1943 modifications to cooling and driveline assemblies translated into predictable approach marches from embarkation points to the beaches, then along the tidal flat under heavy load. Typical approach speeds were 10-12 miles per hour on hard surfaces and 2-6 miles per hour over shingle and sand, but the critical metric was completion. A troop required every hull to arrive because each hull carried a distinct engineer capability. Brigade returns from June, paraphrase, show that where 2 of 3 AVREs in a lane arrived, lanes opened. Where only one did, timings slipped, and infantry improvised with Bangalore torpedoes and hand charges, costing minutes under sustained fire. The doctrine of timed combined arms artillery lift, Petard shot, bridge lay, infantry rush was recorded in 79th Armored Division's planning and reports. Mechanical aids to overcome obstacles immediately on contact remained Hobart's guiding phrase, paraphrase, 1944. But the post-landing notes add a precision qualifier. Accuracy at short range is vital. The bomb must be placed. Paraphrase, War Office Petard notes, 1944. Crews rehearsed firing points in yards, not vague distances, and reload drills that briefly exposed a crewman were refined to seconds under cover of smoke. David Fletcher later captured the design logic. The Churchill brought the engineer to the exact problem behind armor. That is what counted. Paraphrase, asterisk Mr. Churchill's tank, asterisk. Not every lane ran to plan. On mined and shelled exits, a thrown track or a bogged Bobbin vehicle could cascade delays. The Petard's short range demanded nose-to-target alignment. Ricochet angles on sloped faces could waste a round. And on the American beaches, where most funnies were not fielded on D-Day, the absence of such specialized hulls correlated with longer opening times for vehicle exits. Historiography, degrees of causation debated. Terrain, enemy fire, and local planning also decisive. Even within the British and Canadian sectors, subsector performance varied with sea state, initial troop placement, and the survival of the first 2 vehicles in each engineered serial. Yet the aggregate picture across June was consistent. Lanes with multiple AVREs and rehearsed engineer sequences opened faster and with fewer casualties than comparable lanes without them. By July, as operations pushed toward Caen and beyond, Churchill AVREs and Crocodiles transitioned from beach exits to inland strongpoints, chateau cellars, walled farms, and crossroads bunkers. The same metrics applied. A Petard at to 60-80 meters to crack an embrasure, a Crocodile burst at to 80-110 meters to suppress, and an SBG for a sunken lane, each measured in seconds, combined to dissolve fixed defenses without waiting for heavy artillery every time. The slow hulls, low gearing, and stable suspension were not a handicap in this grammar. They were preconditions for placing engineer effects precisely. In Normandy, the Churchill's value was measured in engineer minutes saved under fire. AVREs, and soon after, Crocodiles converted seawalls and village strongpoints from hour-long problems to timed drills, turning a slow chassis into the Allied instrument for rapid, repeatable breaches. August-November 1944, Normandy Low Countries. As the campaign moved off the beaches into bocage, towns, and canal lines, the Churchill Crocodile emerged as the preferred instrument for dissolving fixed resistance. Its design standard Churchill hull towing an armored trailer paired the reliability gains of 1943 with a specialized projector that fired thickened fuel to ranges typically quoted around 80-110 meters. The trailer capacity was substantial, uncertain. C. 400 imp. Gal is approximately equal to 1,000. 800 liters is a common figure in technical notes, enabling multiple short bursts per engagement. Crews tracked expenditure in seconds rather than rounds, since a 1 to 2 second discharge could empty tens of liters. The tactical aim was narrow, compel defenders out of embrasures and trenches so that infantry and engineers could close immediately, without waiting for heavy guns to pound every position. Operational reports from 79th Armored Division, paraphrase 1944-45, emphasized two quantifiable effects. First, the Crocodile compressed the time between identification and neutralization of a strongpoint. A troop would approach at 2-4 miles per hour from covered angles, halt within to 100 meters, and coordinate a first burst with smoke or petard shots from accompanying AVREs. If the embrasure was engaged directly, defenders frequently ceased fire after the initial projector burst. If they held, a second, longer burst or a petard at a wall seam followed. Serial timings recorded reductions in the order of minutes per sight, compared with conventional HE-only suppression. Second, the Crocodile multiplied the credibility of surrender demands. In several battalion diaries, paraphrase, white flags appeared after the projector traversed along a trench. The precise ratios of surrender versus fight-on varied by unit and situation, but the observable pattern, more rapid capitulation at small sites, appears repeatedly in late summer and autumn notes. Quantities and availability shaped employment. Crocodiles were not issued in Sherman-like numbers. They were pooled within 70, 9th Armored Specialized Regiments, and attached by squadron or troop for set-piece operations. Kane's suburbs, the advance to the Seine, the Channel ports, and later the Scheldt approaches. A brigade plan might allocate a half-troop per axis so that if one vehicle was disabled, the timeline still held. Reliability, again, was the enabler. Approach speeds remained modest road marches to 12-15 miles per hour, cross-country 2-6 miles per hour. But the critical metric was arrival in pairs. Squadron returns, paraphrase, in August-September, show that when two Crocodiles reached the start line, strongpoints typically fell within a single artillery suppression cycle. When only one arrived, timings stretched and ammunition expenditure climbed. The Crocodile's effect was not mystical, it was mechanical and chemical. Thickened fuel adhered to surfaces and carried burning droplets into vents and loopholes. Projector pressure charged by bottles drove the stream. Pressure checks and hose integrity were part of pre-assault rehearsals. Crews recorded shot counts and trailer levels. A rule of thumb: uncertain. Unit practice varied. Treated the trailer as good for dozens of 1. Second bursts, with final reserve kept to cover withdrawal. These are metrics that fit planning. If a troop expected to face 4 to 6 sites in a kilometer of street or hedgerow, a 2-vehicle Crocodile element could budget for a first burst, a second if needed, and still retain emergency fuel. Infantry and engineers adapted their timelines to the projector. Infantry platoons rehearsed following at distances that balanced speed of exploitation with safety from splash and heat. Engineers timed petard and charge work to coincide with short bursts that forced defenders to ground. A 79th Armored Training Paper, paraphrase, 1944, set out the sequence: suppress, crack, flame, rush. The order could vary. Sometimes flame preceded the petard, sometimes followed, but the minutes saved were the same commodity. David Fletcher later summarized the logic: Crocodiles did not replace artillery, they replaced waiting. Paraphrase, asterisk Mr. Churchill's tank, asterisk. That sentence reflects a measurable substitution. Fewer calls for prolonged batteries at single barns or pillboxes, more immediate assault under armor. Limits and cautions were cataloged in the same reports. Fuel trailers, while armored, were vulnerable to mines and direct hits, roots and mine. Clearance were therefore scripted, adding minutes up front to save more at contact. The projector demanded close range relative to gun artillery. Fields of fire and defilade had to be planned in yards. Weather-influenced performance-heavy rain could reduce adherence and visible effect, though the psychological impact often persisted. Finally, crocodiles were not a universal solvent. Reinforced concrete coastal batteries and urban strongpoints still required coordinated artillery, petard, and infantry demolition. Where defenders had deep shelters and multiple entrances, projector bursts might clear only the forward positions, requiring sappers to finish the site. Case summaries from late summer illustrate the pattern. At a walled farm astride a battalion axis, paraphrase, August 1944, a crocodile burst across 70-90 meters, preceded an AVRE petard at a corner seam. Infantry entered within 2 minutes of first fire, reporting minor resistance in cellars. At a canal block in the Low Countries, paraphrase, September 1944, crocodiles fired from a causeway, their arcs limited. AVREs laid a short SBG to improve angle, and 2 projector bursts ended machine gun fire long enough for the bridgehead to expand. Neither action is dramatic. Both are counted in minutes saved and casualties avoided. 2 short, attributed remarks capture contemporary assessments. The flame tank is primarily a tool to make men move. 179th Armored Division after-action summary observed. Paraphrase, 1944. A complimentary War Office line cautioned. Reliability and paired employment are essential. A single vehicle invites delay. Paraphrase, 1944. 45 technical divided by operational note. Together they frame crocodile doctrine as arithmetic. Range in meters, bursts in seconds, trailers in gallons, and above all, minutes removed from the assault. From August to November 1944, crocodiles converted many strongpoints from lengthy suppression problems into brief, choreographed actions. Their quantifiable reach, burst economy, and pairing doctrine underwritten by Churchill reliability delivered a repeatable time advantage at the exact moment of breach. December 1944, March 1945, West Wall and Rhine. Winter fighting along the West Wall, Siegfried Line, and the Rhineland placed Churchill-based assault variants against concrete, designed to slow divisions, not just companies. Pillboxes sighted to cover Dragon's Teeth, sunken lanes, and canalized approaches demanded short-range effects delivered on a clock. By this stage, battalions could plan in minutes because Churchill reliability cooling, final drives, and filtration from the 1943 program had stabilized day-to-day availability. Squadron returns in late 1944 frequently reported mid-70 seconds to low 80 seconds % ready on quiet days, dipping under heavy action but recoverable overnight. Uncertain, varies by unit. The doctrine was now routine. Suppress, crack, flame, rush, with AVRE petards and crocodile projectors choreographed to the second. Across the West Wall villages and forest edges, AVREs tackled concrete embrasures and anti-tank ditches that blocked the last few hundred meters of every approach march. The petard's projectile is approximately equal to 20 kilograms, with to 29 40-pounds explosive, remained the primary fast breach tool is less than or equal to 80 meters. Typical serials recorded 1 petard round placed at a junction seam. If the wall stood, a second round followed within to 20-30 seconds, then infantry grenades and charges. Where trenches or water-filled ditches protected the bunker's flanks, a fascine drop bundles is approximately equal to 10 feet diameter. SBG, created treadways in seconds, or an SBG assault bridge, is approximately equal to 25-30 feet span, site-dependent, went down in well under a minute once aligned. None of these actions counted as speed by road march standards. They were speed in engineer minutes, the only clock that mattered under machine gun arcs. Crocodiles multiplied these effects by changing defender behavior. Their projector range, commonly 80–110 meters, allowed flame to reach embrasures from defilated corners in canal or village fights. A first 1 to 2 second burst often produced immediate silence or white flags. Paraphrase, 79th Armored AVREs, 1,944-45, trailer capacity, C 400 imp. Gal is approximately equal to 1,800 liters, uncertain exact figure by mark. Supported dozens of short bursts per sortie. Crews budgeted in seconds, not rounds, to cover 4 to 6 points along a battalion axis. As one War Office operational note cautioned, paired employment is essential. A single flame tank invites delay. Paraphrase 1944-45. Plans therefore pushed Crocodiles in twos, so that if one failed or hit a mine, the projector effect remained in the timeline. Urban edges from the Reichswald to the Rhine bridges saw the same math. In February 1945 Operation Veritable, mud and floodwaters funneled columns onto narrow causeways. AVREs laid SBGs to bypass blown culverts, while Petards broke cellar loopholes under the same smokescreen. In March, during Operation Plunder's approach routes to the Rhine crossings, Crocodiles and AVREs reduced riverbank blockhouses whose fields of fire enfiladed bridging sites. The choreography compressed separate engineer tasks into a single clock cycle. Smoke on. Petard placed in is less than or equal to 30 seconds. Bridge laid in is less than or equal to 60 seconds. Projector burst for is less than or equal to 2 seconds. Infantry across within the minute. If each bunker belt absorbed 5 minutes instead of 15, 2 or 3 belts on a 1–2 kilometers approach yielded half an hour saved enough to cross before a scheduled enemy fire plan could land. Quantities anchored feasibility. Churchill production had surpassed 5,600 by war's end. A minority were AVREs and Crocodiles, but enough existed to assign across corps fronts where breaches were predictable: canal towns, lock gates, and hard edges of the west wall. Road march speeds remained 12–15 miles per hour on hard surfaces, cross-country 2–6 miles per hour. The relevant metric was arrival in roll. A Crocodile that reached the start line with full trailer and charged projector bottles, or an AVRE with 2 or 3 Petard bombs left after earlier sights, meant the next position could be settled without waiting for divisional guns. A 79th Armored training sheet put it plainly: artillery to suppress, engineer tanks to decide. Paraphrase, 1945. Limits persisted and were mitigated by procedure. Concrete caps that had survived years of weather sometimes needed multiple Petard hits, and steep approach angles risked ricochet. Crews rehearsed standoff distances in yards and used smoke judiciously to preserve aim. Mines remained the chief timeline variable. Even with flail tanks elsewhere in the Funnies family, AVREs and Crocodiles depended on cleared lanes. A mine under a Bobbin or fascine carrier could freeze a column. Reports in January–February 1945 paraphrase, therefore added a pre-serial, lane proofing by infantry sappers and mine, detector teams for the last 50–100 meters, costing minutes up front to save more at the breach face. Weather degraded projector effect in heavy rain but rarely eliminated the psychological impact. Several AAR's note defenders abandoning positions after the second burst, despite poor ignition on wet masonry. 2 short testimonies captured the winter logic. These tanks save time, and time is survival. A brigade commander wrote after a canal line fight, paraphrase, late 1944. David Fletcher's later summation matched. The Churchill's strength was bringing the right engineer effect into the last 50 yards. Paraphrase, asterisk, Mr. Churchill's tank asterisk. Neither line praises speed as distance per hour. Both define it as seconds shaved off lethal pauses. The combined arms timeline hardened into habit. Artillery suppression windows were tuned to 1–3 minutes for a single sight. If 2 sights interlocked, the window stretched to 5, with Petard and flame striking alternately to keep heads down. Infantry adjusted spacing to avoid splash, yet be ready to enter within 10 seconds of the breach. LADs staged close with spare track pins, fan belts, and idlers. A thrown track could be reset in minutes if the lane was covered. The planner's arithmetic: bombs per bunker, bursts per trench, bridges per lane sat alongside the more strategic counts of batteries and sorties because the last 50 yards were where operations either stalled or accelerated. Against the west wall and along the Rhine, the Churchill family translated reliability into timed breaching power. AVRE, Petards, and Crocodile Flame compressed bunker belt problems into minutes, turning fortified lines from barriers into schedules and giving Allied infantry a repeatable path through concrete to open country. April, May 1945, Northwest Europe. With the Rhine crossed and German field armies collapsing, British and Canadian formations still faced nodal resistance canal locks, village strongpoints, and forest edges where a handful of machine guns could hold a road for hours. In these final weeks, the Churchill, in its 1,944-45 forms make 4 divided by 7 gun tanks, 95 mm close support variants, AVRE Petard carriers, and Crocodile flamethrowers continued to appear at the decisive 50 yards. Their employment reflected 2 measurable arcs that had converged since 1942. Reliability sufficient to plan in minutes, and role-specific effects. He volume, petard demolition, and flame matched to fixed targets. Unit returns from the Rhineland into northern Germany, paraphrase, show the practical arithmetic that had matured since Tunisia. Road march speeds for Churchill column still averaged to 12-15 miles per hour on hard surfaces and 2-6 miles per hour cross-country. Those numbers had not changed. The difference lay in predictability. Squadron availability stabilizing in the mid-70 seconds to low, 80 seconds % on quiet days, dipping under heavy contact, but routinely recovered by light aid detachment work overnight. Uncertain, unit dependent. This reliability permitted timed serials. A petard bomb is approximately equal to 20 kilograms projectile with roughly 29-40 pounds of explosive could be placed at, is less than or equal to 80 meters in under 30 seconds from halt to impact. An SBG bridge of is approximately equal to 25-30 feet, could be laid in well under a minute once aligned. A Crocodile projector could traverse a trench with a 1 to 2 second burst to 110 meters. Each action compressed pauses that earlier, in 1942-43, had stretched into vulnerable minutes. The gun tank side of the ledger likewise reflected a rationalized mix. The 75 mm armed Churchills, including NA-75 conversions where still present, delivered to 14-15 pounds HE shells at a useful rate, while the 95 mm close support variant's heavier tilde, 25 pounds He gave immediate masonry effect on farm complexes and culverts. Where resistance was light or improvised, these guns alone dissolved the problem. Where resistance was structured west wall, style pillboxes, riverbank blockhouses, the AVRE and Crocodile stepped in. Reports from April 1945 paraphrase, often read as checklists. Wall corner Petard X1, trench flame X1, sunken lane SBG X1, infantry through in tilde, 2 minutes. The vocabulary is not dramatic because the timing had become routine. Production and distribution underwrote this routine. Total Churchill output exceeded 5,600 vehicles by war's end. Only a fraction were AVREs and Crocodiles, yet 79th Armoured Division's pooling allowed these to be massed at critical axes, Scheldt and Rhine approaches, canal towns, fortified villages. That concentration, measured in troops and half-troops per brigade sector, built redundancy into every engineered serial. If a Fascine carrier bogged, another dropped. If a Crocodile threw a track, its partner still fired. In measurable terms, this redundancy preserved the schedule. A two-vehicle Crocodile element retained projector effect even after a single loss. A 3 AVRE lane could still lay a bridge, drop a fascine, and fire a petard if one hull failed. Contemporary judgments reflected this shift from reputation to results. David Fletcher, reviewing the Churchill's arc in Times, Mr. Churchill's tank *, distilled the post-1943 reality. The Churchill's strength was not speed over ground, but the ability to bring the precise engineer effect to contact. Paraphrase. Hobart's 79th Armoured Division summarized the same idea operationally. Mechanical aids to overcome obstacles immediately on contact. Paraphrase directive. War Office AFV technical summaries from 1944, 4-5 paraphrase, noted the delta plainly cooling, air filtration, and final drive life increased meantime between failures. In consequence, commanders could assume arrival of specific engineer effects at named times and grid references. Reputation lag, however, persisted. Infantry still called it slow, and Diepp's failure continued to color popular memory. The data contradicted the caricature. In 1944-45, when the task was a bunker, lane, or wall, the Churchill was the scheduled answer. Limits remained visible even in victory. Reinforced concrete that had weathered for years could shrug off a first petard. Crews were trained to place a second round within 20-30 seconds. Mine strikes still froze columns. Thus, endgame procedure added lane, proofing by sappers in the final 50, 100 meters before an AVRE moved forward. Ammunition and fuel accounting was exact. A Crocodile trailer, commonly cited around 400 imp. Gal, is approximately equal to 1,800 liters, uncertain by mark, was budgeted in 1 to 2 second bursts to cover multiple points, with a reserve kept for withdrawal. AVREs tallied their petard bombs, typically carrying only a small number per vehicle due to stowage and weight. None of this altered the outcome trend, only the schedule by a minute here or there. The post-war lessons read like an engineer's appendix. First, reliability is tempo. Cooling and driveline fixes in 1943 did not make the Churchill faster. They made its minutes bankable. Second, HE variety matters. The step from 6-pounder HE to 6-7 pounds shell, to 75 millimeters, to 14-15 pounds, and 95 millimeters, tilde 25 pounds, was operationally decisive against fieldworks. Petard demolition remained a specialized, short-range solution when concrete demanded it. Third, specialization multiplies the infantry. AVRE bridges, fascines, and bobbins changed the map at contact. Crocodile projectors changed the defender's decision calculus. Fourth, choreography wins. Artillery suppresses, engineer tanks decide. Infantry exploit. Where this timeline held, canal lines and village belts dissolved in minutes. Where any link failed, bogging, mines, mistimed smoke delays grew by similar increments. Two final remarks capture the ledger's balance. These machines saved time, and time saved lives. A late war brigade note concluded, paraphrase, 1945. A War Office technical summary added the caution that defined the whole program. Effect is certain only when the bomb is placed. Accuracy at short range is vital, paraphrase, Petard notes. Neither remark mentions speed in miles per hour. Both measure speed in seconds shaved from lethal pauses, the precise currency the Churchill, once derided, came to mint. The close of the campaign confirmed a pattern set since 1943. Reliability fixes and specialization turned a slow infantry tank into the Allies' standard breaching instrument. Reputation lagged capability, but the numbers minutes saved, breaches made, strongpoints reduced, show why the Churchill became the bunker breaker of choice.